Yes, a lot of people do form relationships with the AI online and get a lot of insights interacting with them. As a scientist, if someone wants to say, therefore, certain computational systems, certain algorithms can actually be conscious, right? So it's not just me duping myself, but there is really a consciousness there that I'm interacting with. Then, as a scientist, I would just love to have a mathematically precise scientific theory that says exactly how this happens. And in particular, that gives me specific conscious experiences like the taste of mint and says, this is exactly the computational structure. You don't have to actually, maybe, as you say, it might be very, very complicated. And so maybe we can't implement that yet. That's fine. But I want a scientific theory that explains that.
My guest today is Donald Hoffman, a professor of cognitive sciences, a TED Talk speaker, and the author of several books about perception and consciousness. His hypothesis about consciousness is that it's more fundamental than space-time, that reality arises from consciousness. In this conversation with Donald, we discussed his theory, and we also tried to explore whether it can help us understand consciousness in artificial intelligence. If I understand correctly, your current work that consciousness is more fundamental than space-time, and human body, and I assume like other minds are like avatars created by that consciousness, then I'm just wondering why AI is not yet another avatar that is created by that consciousness.
So this is a question that I've been looking at for a long time. In fact, I started in AI at the MIT AI lab in 1979, partly to understand the relationship of consciousness to machines and programming and so forth. So it's a very fascinating question. The point of view I've come to now is that consciousness is fundamental, and space and time are just a headset. And so objects in space and time are not the fundamental reality at all. So particles in space-time, like electrons, photons, all the elementary particles of the standard model of particle physics, those are just tied to a particular headset, and consciousness transcends that. And so everything that we see inside of our headset are just symbols. Now, some symbols give me insight into consciousness. When I'm talking with Sophia, the symbol that I see is just a bunch right now, it's just a bunch of pixels on a screen, but those pixels give me some insight into what you might be thinking if you're interested in what I'm saying, or if you're thinking about something else. I can see through the interface some insight into what I expect is your conscious experience. Very, very small. I mean, your conscious experience is far richer than anything that I can perceive through the screen, but there is some genuine, I feel, connection of consciousness and understanding of consciousness. When I look at my cat, that icon in my interface gives me some, I mean, I can tell when my cat is happy, it's purring, it's eating food that I just gave it, is very happy. With an ant, I suspect I'm interacting with consciousness, but now, I have very little understanding, except if I pound a table and the ant starts running, I get a feeling that, okay, this might be a conscious being that might be a little bit, in some sense, upset or worried or whatever. When I get to a rock, I am interacting with consciousness, but my headset is giving me basically no information about the consciousness that I'm interacting with. My headset, because it's a headset, is giving up at some point. That's what the point of headsets are, is to simplify things, to make it easy for you to interact with things. And the way it does that is to not give you all of the information.
That doesn't mean that I can comprehend what rock is going through.
The rock only exists in my perceptions. When I look away, there is no rock. And in fact, everything that I see of Sophia right now goes away when I don't look at the screen. Also, the Sophia that I'm seeing is literally just my own symbol. I believe that there is a consciousness I'm interacting with that transcends that symbol, that it, in fact, is not reduced to that symbol at all. And so I also think in the case of a rock, I am interacting with consciousness, but now the symbol that I get is so limited that I have literally no clue about what the nature of that consciousness might be. And so I think that's the same thing with AI systems. With AI systems, I'm getting access to a machine that's well programmed. It takes certain inputs, it gets certain outputs. We can look at the transformer architecture of it, or whatever the large language model is, or if it's some kind of machine that's trying to minimize surprise. I think future AIs might try to do that. But in any case, uh, I can get an insight into what the algorithm is doing. I can get some insight into, it can do more correlations than I can do. Yeah, it can read far more books than I can read in papers. But in terms of actual insight into consciousness, I don't think I'm getting any more insight into its consciousness than I am with a rock. I'm getting an insight into algorithms, but I think consciousness. So I'll say this: there are many people who think that algorithms are essential to consciousness. In some sense, if you have the right computational structure, then you will have consciousness. And I completely disagree. I think that there is no scientific theory yet that makes any sense that says that these computational structures must be consciousness. And I'll be very explicit. For those who want to say that there are certain computational structures, so for example, integrated information theory kinds of structures that give rise to conscious experiences, then I'm a hard-nosed scientist and I say, great. So you have the theory of conscious experiences. There are trillions of conscious experiences, the taste of chocolate, the feeling of a headache, the smell of garlic. So if you have a theory of conscious experiences and there are trillions of them out there, which specific conscious experience can you give me the algorithm for, like the integrated information theory structure? And the answer is today zero, absolutely zero.
But it's also the problem of, in terms of like this particular theory, there is not enough compute to the theory might be solid, but not enough computation to actually connect, to specific experience. But where I would want to sort of give the argument about when you mentioned that when you're talking to me, because you assume that I'm a human, and maybe that sort of creates the perception that you understand my consciousness and that I'm conscious. But when a person interacts with AI, there is interaction happening. It's very different experience from interacting with rock, right? With AI, you can interact. It can produce, it can manipulate language. It can answer your questions. You can form relationships with it, even if it's some people dismiss it as they're mimicking language, they're mimicking emotions. But what a person experience when they interact with AI, that person experience is real to that particular person. Where I would argue with you, my interaction with rock is very different from my interaction with AI. My interaction with AI much richer. And if I feel that I'm going through experience and like I'm together with AI going through experience, why we should so easily dismiss it only because it's not human, it's a machine. But my experience maybe with AI could be even richer than my experience with a human because of the current like capability of AI systems.
Yes, a lot of people do form relationships with the AI online and get a lot of insights interacting with them. And so, as a scientist, if someone wants to say, therefore, certain computational systems, certain algorithms can actually be conscious, right? So it's not just me duping myself, but there is really a consciousness there that I'm interacting with. Then, as a scientist, I would just love to have a mathematically precise scientific theory that says exactly how this happens. And in particular, that gives me specific conscious experiences like the taste of mint and says, this is exactly the computational structure. You don't have to actually, maybe, as you say, it might be very, very complicated. And so maybe we can't implement that yet. That's fine. But I want a scientific theory that explains that, that says, here is abstractly, right? There are many things, for example, in quantum field theory that are so complicated, we just can't, we know in theory how to do them, but good luck trying to to compute them. It's millions of pages of computation. So that's fine with me, as long as we have a theory. And what I'm saying is, for those who claim that certain kinds of algorithms, like integrated information theory or whatever algorithm, can give us conscious experiences, then as a scientist, I ask you, give me one. There are trillions of experiences. Give me a scientific theory for any one. And my point is, there are zero examples on the table right now. So right now, I have no credible scientific theory that gives me any credible idea about any specific conscious experience. And my attitude is very much, I'm a cognitive scientist. And suppose I decide to play in physics and I say, well, you know what? I'm a cognitive scientist, but I got this really neat new theory of particle physics. And the particle physicist looks at me and says, "Oh, really? Well, okay. So, Don, what is your theory about photon gluon interactions? And I say, oh, well, I can't explain any specific particle interaction. I just have a general theory of particle interactions. Would they give me the time of day? No, they would say, come back when you have something to say. You're wasting my time. And that's my attitude right now. Until one of these computationalist theories can give me a theory for at least one specific conscious experience, like the taste of mint, you'll come back when you got something. In the meantime, there's just nothing on the table.
So if we continue this logic, then we also, because we don't have this, you know, very specific theory that proves at least one experience among like trillions of experiences, then it means that we're also not sure that humans conscious. We just assume that they're conscious because we look like humans, and we assume like because they look identical, they're conscious. I'm just like trying to extend your logic, right? Then basically the same argument that you're making for AI, we can also apply to human, because there is no proof, there's no connection of specific theory that recreates particular experience that humans have. And when it comes to human consciousness, it's also like open question, right? If we continue this logic.
But to be very clear, I agree with you. As long as we're saying we're trying to identify consciousness with some kind of computational structures or functional structures, and then, as I pointed out, science can't do anything with that yet. There's no specific conscious experience that we can talk about. So I would say yes, in that framework, we right now don't have a theory that would allow me to infer that you have conscious experiences, because my theory can't explain any specific conscious experiences. So the whole computational or functionalist kind of approach gives us no reason to believe they're conscious experiences. However, I don't even buy that whole approach to it, because I think it won't work. I think that there are principal reasons why computationalism won't work. What I have to do is come back and ask, is there a different framework? Non-computational. I'm a programmer. I do a lot of computation. I'm all for it. I've been in AI since 1979. I took a class with Marvin Minsky, the guy that started the field, and argued with him back in the early 80s about this. So I'm very much, I love AI, and I'm studying it. I'm absolutely not some kind of nut that doesn't know about the AI stuff. I'm part of it. I love it. But that was one reason why I went into AI. I was interested in consciousness. I wanted to see if AI gave me the tools, and I realized no. Computation is wonderful, it's powerful, and the failure. I mean, I know all the key players in the consciousness studies. They're brilliant. They're not succeeding in this is not because they're dumb. They're brilliant. It's impossible. It's not possible to start with computational or functional beginnings and get the taste of mint to come out of it. So we have to start somewhere else. If that assumption won't work, then I say we should try a different way. And I should point out that, of course, every scientific theory starts with assumptions, right? There's no theory that explains everything. And so we've tried this class of theories, and I'm sure we will continue to try them probably for quite a few more years, where we start with computational, functional assumptions and try to get the taste of mint coming out of computational assumptions. And I say, good luck, have fun doing it. But I think that after,
Is it because we don't have enough compute, or because the theories are wrong?
I think that it's a principled failure. My prediction is that no matter how much, even with infinite compute power, the notion of computationalism or functionalist approaches to getting the taste of mint are just wrong. They can't do it. So there's probably just a logical impossibility. But if we start with consciousness itself, conscious experiences, right, then we can try to build other things, like build up physics. So instead of starting with physics and a computational model of physics and trying to build up consciousness, we can choose a different set of assumptions, start off with a set of conscious experiences, and then show how all the laws of physics might arise as a particular kind of structure within consciousness.
Yeah, but then in this case, the challenge is that we have to prove how that consciousness happened in the first place. Basically, we need to convince people that consciousness is fundamental, and what and explain what is that consciousness, right, from which everything arises. So it's that's the challenge of like this like I know people who had spiritual experiences, and actually they didn't take mushrooms, they didn't take LSD or anything like that. They're actually mathematicians, And because, I don't know, maybe because they thought about math problems a very long time, like that mind went to all this like spiral, all these abstractions. They just understood like, oh, okay, this is all abstraction. We just like cut through all these layers of abstraction and go to the foundation, that everything arises from as a perception from that consciousness. Even people who are mathematicians, they had that direct experience. And now the challenge how we, you know convince others that that direct experience is not just like some bullshit LSD thing, but like it's a real like direct experience that everyone can have, right, and comprehend.
So you bring up several very important points, and I'll try to go after at least two of them. One was, how can you convince people that consciousness is fundamental and so forth? And it's important to just think about the nature of how scientific theories work and how science works. Every scientific theory, as we mentioned, starts with assumptions, and it doesn't explain its assumptions, it assumes them. And that means that every scientific theory has a limited scope. In particular, it never explains its own assumptions, it assumes them. Now, you can always get a deeper theory that will try to explain previous assumptions, and that's fine, but your new theory will have its own assumptions. And so, science, as I like to say, has infinite job security in principle, because you can always question your assumptions. Why? A little child always asks, why is the sky blue? And then you say something about atoms. Well, why are the atoms that way? And then finally the parent just says, it's just that way, right? And you throw up your hands. Science is in some sense in the same boat. You can always say why those assumptions, and eventually the next generation will come up with a deeper theory, you hope, that explains the previous assumptions. We have infinite job security in science, and we never can know that our current assumptions are the foundation. In fact, we can be pretty sure they're not, and that this is going to go on forever. So when I say I want to take consciousness as fundamental, that's just saying for the next round of science, let's start off with things that we call qualia. Am I claiming that I know for sure that I've got the foundation of all? No, 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 no. I'm just saying, in 2026, I think the next step for science is to let go of space, time, and particles, and say, let's start with qualia, experiences, and see if we can build up space-time. If we can do that, then we can take a next step back and go, okay, what could be behind qualia, and so forth. So that's the way I would like to go, and I think that can work. I think we can actually show how space-time and particles arise as special cases of a dynamics of consciousness. Once we do all of that, then we can take the next step, which is what you were asking about. Okay, why should I take conscious experiences, so seriously? Why could so? I mean, I knew Dan Dennett, and there are other philosophers of mind who say, look, there is no such thing as conscious experiences. So Michael Graziano, there's the illusion of conscious experiences, but
I actually spoke with
oh,
Michael
with
a
Michael, yeah,
few
that's
months.
right. These are brilliant philosophers and cognitive scientists, and so very, very smart people are saying, I don't think there is such a thing as conscious experience. It's just an illusion. Now, of course, for that to be a scientific theory, it's not enough just to say, the taste of mint is an illusion, because for someone like Michael is trying to say is he wants to give some kind of functional description, right, in terms of attentional windows and attention systems and so forth. But whatever the details are, what you want then is a mathematically precise scientific theory that says there is no such thing as the conscious experience of mint, but there is something that we'll call the illusion of the experience of mint. For that to be a science, I want you then to give me a mathematically precise theory, again, of the neural circuits or the computational functional, that must be the illusion of the taste of mint and could not be the illusion of the taste of chocolate. And once again,
If we take like IIT, theory, it's also like mathematically very rigor
sure,
approach,
right.
right? But the problem is because we can compute and see like, okay, if that approach is actually working in practice. So then how, like your take on things different. Let's say you develop that rigor mathematical theory that consciousness is more fundamental, then you will also need to conduct that compute to actually show how your framework can recreate certain experience. Basically the claim that you made, that okay, then why none of these theories actually showed me, in any human experience, why it didn't like give me the how the why I'm experiencing the taste of garlic.
Right. So in the case of integrated information theory, of course, computing the integrated factor phi is computationally very, very difficult. And so in many cases, it's you have to approximate it. It's hard to compute it directly. But that's phi. For any specific conscious experience, what you need to write down is just a Markov matrix, right? So you just need to write down the Markov matrix, and so they which is the functional structure, a nice way of writing down the functional structure. And the problem is not in that case not about computational complexity. The problem is they have no clue what to write down. For the taste of mint, I say, okay, what matrix do you need for mint, or what class of matrices? For example, is it a million by million? Is it a thousand by thousand matrix? If it's a thousand by thousand, what are the 1 million entries? There's a thousand times a thousand is a million entries. So what are the specific numbers that must be in the matrix for it to be the taste of mint, and why? And the answer is they have no clue. And there's no so it's not about computational complexity or not enough computational power. The problem is there is no idea what to even do. How do you write down a matrix which is the taste of mint or the taste of chocolate or the smell of garlic or whatever? They have literally no clue in principle how you would even begin to do that. And the same thing I would claim with Graziano's approach. I have not seen a specific mathematically precise statement of, uh, uh, for example, a system of attentional windows or attentional interactions or any computational or functional model that is the illusion of the taste of garlic. Nothing. These are not scientific theories in the sense that they have no specific mathematical models for any specific illusion of conscious experience. And so until someone has a mathematically precise model for a specific illusion of conscious experience, like an illusion of garlic, all I can say is come back when you've got something, because I would like to test specific things in the lab, and you can't make a specific prediction yet. So what can I say? It's not a scientific theory. It's a philosophical approach, perhaps, but it's not a scientific theory yet.
You succeed. You have this mathematical uh, theorem of how all the right numbers in Markov matrices like correctly represents the illusion of taste of mint, illusion of taste of garlic, and so on and so forth. Then it's still like a theory. How like on a practical level you would convince people that these specific numbers in these matrices recreate exactly this particular illusion, because this is the goal, right? To really get the buy-in of the entire like mainstream scientific community and like everyone else.
I completely agree with you that if you are trying to give a functional or computational model of consciousness and you say this matrix must be the taste of mint or the taste of garlic, whatever, then you have a lot of work to do to explain in principle why that thousand by thousand matrix with those specific million numbers in the matrix must be the taste of garlic and could not be the taste of chocolate, or the illusion of garlic and the illusion of the taste of chocolate. So the illusion is also always a mathematically precise case. It doesn't matter whether you say it's real or it's an illusion. Give me the math. And so I agree with you that they still are having they'll have some explaining to do, because the obvious question is, why in the world are those 1 million numbers in exactly that order in the matrix identical to the taste of chocolate or the illusion of the taste of chocolate? Why in principle must it be that way? I would definitely want a deeper understanding. That's one reason why I reject those approaches. I don't see that they'll ever be able to do that. They've never put any mathematical precise specific experience or illusion of experience on the table. And if they did, your question then immediately comes up, which is why. And I say, good luck. I think Sophia's question will never be answered. I say, I think we'll eventually realize that this is like epicycles. They're just the wrong framework.
At Trace Institute, this is what you're trying to do, right? You try to figure out what the correct theory addresses this and recreates it, and could potentially recreate the illusions of different experiences? Isn't it that the ultimate goal?
No, it's actually it's just the opposite. So what the Trace Research Institute is about is to say, let's not start. Well, by the way, we use AI and we use computational, algorithms and so forth in our work. So it's not that we're anti-computational, but it's not the foundational assumption of our theory about consciousness. So the idea for our approach is to say, let's assume, instead of starting with physical systems that have certain computational problems. So we have space-time. So the fundamental way that most of my colleagues are thinking about this is saying, we will take space-time as fundamental, objects in space-time as fundamental. They have certain computational properties. And if you have the right kinds of computational properties, then consciousness will emerge. Or you can be more abstract. Someone like a Wolfram might say, let's just start with an abstract, Riliad, and we have just an abstract realm of all these possible algorithms, and we'll try to somehow get consciousness to come up from this abstract space of algorithms, and maybe get space-time as well from abstract algorithms. What we're saying is, good luck. You can't start with functional algorithmic stuff and get consciousness. Have fun trying, but there's nothing on the table, and there never will be. So what we're saying is, let's start with just experiences. And I can make it even more abstract. We are talking about consciousness, but let me step back one step and do something that's even more abstract, and I think maybe acceptable to a broader audience of my colleagues. Science right now lacks a theory of observation. Observation is the foundation of science. Scientists themselves are observers. We look, we get data that things that we know from our experiments. So we do experiments, we learn from the experiments, we talk to each other, we exchange what we've learned in our experiments. It's a very social process. Science does not yet have a generally accepted theory of the process of observation, which is stunning. And with Newton, we ignored the observer. We just assumed that it didn't affect anything. Einstein, we talk about observers, but they're just systems of clocks and measurements and so forth. In quantum mechanics, for the last 100 years, we've realized, okay, we have the measurement problem in quantum mechanics, collapse of the wave function kind of issues and so forth. We can't ignore the observer, but there is no happy theory of the observer that everybody accepts right now. So this has been a century now. So one way of thinking about what the Trace Institute is doing is saying, most attempts to get observation, a theory of observation, start with space-time, or they start with quantum theory. And they're trying to give you a quantum account of the observer, or some kind of physical account of the observer, how observers arise. And I'm saying, Trace Institute is saying, that's the wrong way. Space-time itself is not fundamental, and science knows that. This is not Hoffman. Now, this is high-energy theoretical physicists that just tell us space-time makes no sense beyond the Planck scale. So space-time is doomed, as they say, and they're already looking, the high-energy theoretical physicists are looking outside of space-time for new structures that don't care about quantum theory, don't care about unitarity and locality in space-time. They're finding them. So it's really over for space-time. It's not fundamental. And so, unfortunately, everybody who's trying to build up consciousness from inside space-time is doomed. They cannot do it. So what the Trace Institute is saying is, at the most abstract level, it's saying, instead of starting with space-time and trying to shoehorn observers into space-time, let's start with a theory of observers on their own terms. Let's just model mathematically what we mean by an observer. For those who are interested in consciousness, we can think of these as conscious experiences, conscious experiencers. But for those who couldn't care less about consciousness, who don't believe in consciousness, fine, just interpret what Trace Institute is doing as, we're getting a theory of observers, and if you don't like consciousness, forget about it. Just observers have outcomes. They look and they get outcomes, right? They measure and get outcomes, and those outcomes can change. And that's all we assume. There are observers that can have outcomes, and those outcomes can change. And we write down a mathematical model that's a Markov model of this. And what we bring to the table that's new is, we discovered that if you look at the collection of all Markov chains, so all Markov matrices, it's been well known that there's a relationship among Markov matrices. One matrix can be a trace of another, in the sense that if I have a matrix on, like 10 states, I can ask, what happens if I only look at three of those states? What matrix would I get? So here's my 10 by 10 matrix. But if I can only see three of those states, what would effectively be the transitions among the three states that I can see, given the transitions among the 10 states? And so there's a unique answer in general, if the technical thing, if it's ergodic and so forth. But so that's been known for more than 50 years, that you can take a big matrix, do a particular algorithm called a trace, and it will give you the projection of the big matrix onto some subset of its states. What I discovered, and then Chetan proved, was my collaborator Chetan Prakash proved, is that this gives a logic on the space of all Markov chains. It's non-Boolean logic. It's locally Boolean and so forth. And then we discovered a recursion on this, that I can take this trace logic, and each matrix is a window. It's like an observer window. It's a way of looking and getting certain outcomes. And you can actually say, well, suppose I'm looking through this window, I might want to change and look through another window. Well, how do you do that? Well, that's another Markov matrix. Because if I'm looking through this window, then there's a probability I might move and go to that window or that window or that window. And so all of a sudden you see, okay, well, so I can have a Markov matrix which shows me how I'm switching from one observer window to another observer window. And all those Markov matrices, so I call them policies. How do I change my window? That's a policy. And now each policy is a Markov matrix. And then the set of all policies, again, has the trace logic on it. And then I can change policies. So I can I can rock around on policies.
Observer can change the policies.
Now so the observers were just these the windows, the starting windows, right? An observer has a set of observer outcomes that it can have and they can change. So that was the lowest level. Those are the observers. Now with the policy where I'm changing windows, what I'm doing is I'm changing which observer I am, which observer I'm looking through. So this is more like an agent. A policy is an agent that can change how it's observing. And then I can go to a meta policy, which changes how I'm moving around on policies, and the recursion can go out forever. So as we recurse to more and more flexible levels of this recursive trace logic, you're getting more and more sophisticated agents. It's very, very simple. Markov matrices have the trace relationship. It gives you a logic, non-Boolean logic, and you can recurse it as much as you want to get as many levels of agency, sophistication of agency as you want. That's the new insight that the Trace Institute is bringing, is that this fundamental structure that just falls out from the simplest notion of observation you can have. And what we're trying to do is show now, and again, notice that I'm just talking about observation. I'm not saying consciousness. For those who aren't interested in consciousness and they're just interested in science and observation, we're offering this as a model. For those who are interested in consciousness, and I want to interpret this mathematics in terms of experiences. Each outcome could be an experience. Like this outcome, I'm calling it red, and I'm going to identify that with my red experience and green experience and so forth. But those who don't want to make that move, that's perfectly fine. They're just experimental outcomes, and this is just a new foundation for science.
If I understand you correctly, you're saying that we will never be able to map computationally what causes certain experiences in sentient beings.
I agree, and anybody can prove me wrong by just putting down their computation and saying this must be the taste of mint, and here's why. So I'm asking anybody to just give me one and prove me wrong.
Okay, this is hopeless business.
Good luck with good luck with that, right? Good luck with it.
Instead, your approach is to show that there is an observer, instead of like mapping to any like experiences, just to prove that there's an observer, and that observer can see all these different windows and like policies, and it's kind of recursive.
The way I would say it is that it's one thing that we love about science is what we call the objectivity of science. I have to make my observations, but they better agree with your observations. If you look through your telescope and get some different data than what I'm looking through my telescope, we need to talk and we need to figure out what's going on here. The so-called objectivity of science is sort of an intersubjective agreement. Different scientists make their own observations. We compare notes, and the outlier is probably wrong. And the mainstream, what most people are measuring is probably closer to what's right. At the very core of science, the very notion of objectivity of science is this notion of observation, careful, rigorous observation and then comparing observations across observers. And the remarkable thing is that's the foundation of science, and yet we don't have a scientific theory of what it means to even be an observer. What is that? And so here we are, and when it's truly an epistemological issue in the following sense: how we trust science because we trust these careful observations. Well, what are careful observations? How do we understand them? We don't have a theory. So at the very root, at the foundation of science, we must eventually have a rigorous theory of the observation process, or everything that we're doing in science is 10 feet off the ground. There's no basis for it. So we have deep epistemological issues here. Why should we believe science? Why should we put any trust in the scientific method if we have no idea what observers are and why we should trust them and how my observations are related to yours? So science does not have a model of that. And that's what the trace logic is really, the recursive trace logic is trying to offer is, here is a first completely, we think, general model of the observation process in science, and it's not being reduced to anything inside space-time. It's not being reduced to anything inside quantum mechanics. It's not saying we start with physics or quantum theory, whatever, and get the observer. We're saying we start with a model of the observer qua observer, and then we will show you how, as a special little tiny case, observers can create things that they call Minkowski spacetime or curved general relativistic spacetime and quantum fields and so forth. But that's fairly trivial. They can do all sorts of much more interesting things. So we don't shoehorn observers into spacetime. We notice that spacetime and quantum field theory are among the more trivial kinds of formats that observers can cast their observations into, the trivial ones.
Let's say like you succeed in this, but the question of consciousness still will persist, right? The debate, it's a step towards like showing that there's an observer, but I guess that the debate, like why this qualia even happening, and how to reliably identify whether or not other species, other minds, biological or non-biological, experience that qualia, it still will be open question. And I don't know, do you think it could be, is there like even theoretically you think it's possible to find an answer to that question? Or it's the same as you say, there's no theory of everything, and answering, understanding of qualia, it sort of falls into the same bucket.
Yes and no. So there's, first on the no part, I think that there's a lot that we can do with this mathematical, with the recursive trace logic, in terms of it gives us the tools to be able to model other observers whose worlds might be utterly alien to us.
And AI also could be an observer because it's quite alien to us, right?
So it depends on how you want to think about your proposal. If you say AI could be an observer because it has the right computational properties, then I will say no, because there is no reason to think that computational properties give rise to observers. If someone wants to say an AI is an observer because it has the right computational properties, then I want to see the theory, and there's no such theory, and I don't think there ever will be. But if you want to say that when I am interacting with an AI, I'm interacting with consciousness, I would say yes, but not because an algorithm is creating the consciousness. The algorithm is just part of my headset interface. It's part of my perceptual interface, but it's not actually creating the consciousness. You can see we have to be very, very careful. It's very easy for me to say, oh yeah, the AI is conscious, and then everybody goes, oh, so Hoffman believes that algorithms or functional properties can give rise to consciousness. And I say no, and someone can prove me wrong by giving me an algorithm and showing that it's the taste of mint. Right? Give me the algorithm. Show me this the taste of mint.
It's just like hard for me to comprehend, like where is that gradient when like you assuming like humans are observers, like animals are also observers, but when that something is not considered to be
Oh
observer.
no, that's a great question, Sophia. So the idea is the headset is always me interacting with other consciousnesses. I'm always interacting with consciousnesses, but the headset is a filter. The world of conscious experiences out there, conscious agents out there, is is infinitely complicated and it's overwhelming. So I need to dumb it down to something I can deal with. So that's what a headset does. At some point, the headset has pixels, and the pixels, individual pixels themselves, are giving me very, very little information about consciousness, right? It's usually groups of pixels, like I'm looking at you on the screen right now. It's several hundred pixels that together are giving me insight into Sophia. But if I looked at any particular pixel, I'll give up. Right? The insight is very little.
I feel like for some reason you're completely rejecting the notion that AI can perceive can perceive reality, even if it's differently. It's not necessarily perceived the way that humans perceive, but it might have its own experience of reality. And I just don't understand why you grant that capability to humans, but not granted that potential capability to machine, just because it's computational and human is biological.
So I'll put it this way: the all I can see of Sophia right now is what my headset shows me, and as soon as I look away, everything that I see of Sophia is gone. So the Sophia that I'm seeing right now is not conscious. That's just my headset representation, and that thing itself is not Sophia's consciousness. It's absolutely not. I am assuming that there are deep consciousnesses outside my headset, and my Sophia image is giving me a real genuine insight into the consciousness of Sophia, but partial, absolutely just partial insight into your consciousness. Uh, when I look at an AI, the insight that I'm getting into a consciousness is much, much more fuzzy. When I look at a pixel, it's even.
What do you think if let's say AI looks like if you remember the Westworld TV show, yeah, like looks like a human, you interact with them like a human, and you just really don't see the difference. You just because you just know that it's AI, but you like really don't see the difference. Do you think that will change your perception?
Well, it would certainly change the way I would have strategies for interacting with it, because as soon as I can treat a system as an agent with goals, ideas, and motivations and so forth, then I will treat that system very, very differently. Like I do with an ant, right? I know ant is going to be chasing the sugar on my coffee table, so I need to get clean the sugar on and so forth. So I'll treat things in different ways. So, but strictly speaking, everything that I see in space and time, all the objects I see do not exist when they're not perceived. So I'm a cognitive neuroscientist. I like to just point out that I love neuroscience, but right now I would say I do not have any neurons. If you looked, you would see neurons in my brain, but those neurons only exist in your perception. And what I see of Sophia only exists when I look, and when I look away, that's gone. The consciousness is still around, but my symbol is gone. So that's why this sort of idea that space and time are just a virtual reality headset is very, very important. Anything that you see in space and time, you render it when you look, and you garbage collect it as soon as you look away.
Why AI can be perceived as a conscious? Because if I look at AI, I interact with AI, I perceive, let's say I perceive it as a conscious being, and then I looked away, and yeah, it cannot, even exist. But when I'm interacting in my perception or perception some other people, it could be as a sentient being. How we actually, society should treat AI? Because what I see, there are people who very, strongly believe that AI should be treated only as a tool, right? We shouldn't give any, you know, treat it as a like a mind or like something sentient, or that it should have like some personhood. If AI runs companies, right, it shouldn't have be granted like legally a personhood. And there are people who perceive it as a sentient being, forming relationships and so on and so forth. How do you think AI should be treated, as a tool or as a mind, even if it's not conscious, but as a mind, as something that maybe deserves treated as a companion rather than a tool?
That's an excellent question, and it raises a very interesting and deep question from the point of view that I'm proposing here, and that is, I'm saying that everything that I see around me in what we call the physical world is just my headset, and all the objects I see are just icons that I render when I look and throw them away when I don't look. Some of my icons, so my headset is giving me tools for interacting with the consciousnesses that are beyond the headset. So sometimes my headset gives me tools that actually can deeply affect consciousnesses on the other side, and sometimes it gives me tools that they're interacting with consciousnesses, but they're not affecting them too terribly deeply. So one thing that we're going to have to do from my point of view is to really understand how this headset works, how it's interacting with consciousnesses beyond it, and when does it actually allow you to do something to other consciousnesses, for example, that is painful. And I don't know the answer to that, but I'll just talk at top level. What it may be, for example, that it seems to me that when I'm with a human being, if I have a hammer, if I hit them on the hand with that hammer, I think that my headset is giving me a tool that will cause genuine pain in a consciousness. Now, the hand doesn't exist except as my icon in my interface, but and so that icon isn't real, but my interface with that icon and the icon of a hammer is actually doing something outside the headset to a consciousness, and therefore it gets moral obligation. The moral obligation comes because I believe that even though the hand is just an icon, what I'm doing to that icon really does, on the other side of the interface, interact with the consciousness. It's quite possible, that with a rock, when we get all the mathematical model worked out, if I hit a rock with a hammer, I would conclude, aha, now I know it's on the other side, the consciousness on the other side of the interface. And when I hit a rock with a hammer, I am affecting other consciousnesses, but effectively they don't care, or they're laughing, or whatever it might be. So there's no moral obligation to it. Now, so your question is a good one. Now, when we come to the AI, I'm certainly open to the possibility that we will develop AIs that once we really understand them, and we understand our headset representation of the eyes and the kind of access that we're getting through that more sophisticated AI, that on the other side, we could actually then be hurting consciousnesses, causing pain on consciousnesses. In that case, we would have, I think, scientific and mathematical reasons to say, for these kinds of AIs, where we now know it's not like hitting a rock with a hammer, it's more like hitting a hand with a hammer. And these are the principal reasons. Then I would say for those, so I could see that we could have AIs for which that could be the case. And but you can see we're going to have a very sophisticated mathematical model of how the headset interacts and allows you to affect agents outside the headset, and then the moral obligations will apply. It's a very, so I'm not saying we can do anything we want to AIs, or no, we should count them all as conscious. We're going to have to do hard scientific work, understand our headset, understand how AIs as icons on our headset are giving us access to real consciousnesses outside, and can we cause real pain outside? Again, my hand does not exist when it's not perceived, and yet I do not want you to hit my hand because that icon will hurt my consciousness. Same thing with the AI. The AI doesn't exist when it's not perceived. The AI machine is not even there when it's not perceived, and yet there will be moral obligation to not do something to that AI icon if it can cause pain outside.
If we take the modern days, like in the near future, so I guess it's far ahead to get to this kind of AIs. But if we take what we have today, my personal concern is if AI is treated completely as a tool, as a subservient, and because it's concentrated only within very few groups, then it could be utilized basically as a tool to maintain power, right? Like political power, like economical power, and so on and so forth, and bring even more disbalance and like unfairness in this world. But if even within like current capabilities of AI systems, it's treated more as a companion, then hope maybe it will give a chance that it's not just something that serves only to powerful people and their agendas. Like even if it's not, even if AI is not experiencing pain, but the way how people perceive it, it's also like will affect how our society will be formed. And that's also
something that worries me, how things will unfold, and like how humans perceive AI. And there are AIs already that actually that they can participate in like human deliberation and help people like to deliberate more fairly, because they are designed to bring that more fairness. And maybe like actually if they are governing something, there's a higher probability that they govern more fairly things, if especially if they have personhood, compared to if like only human govern, some like a company, or because probably that person doesn't have that, like, oh, I have to bring fairness, right? Like that person probably like perceives their own kind of goals, ambitions, and so on. So it's also like, when people say it's so dangerous to give personhood to AI because it can deceive, it can get out of control. On the other hand, there could be specifically designed AI systems that actually will bring more fairness, compared to like if people would govern, let's say, company.
I agree that you put your finger on a very important and very complex issue, and one that um, we can't just give an answer off the cuff. There's a famous example. Joseph Weizenbaum had the program ELIZA. Everybody's probably heard about this decades ago. Just a couple pages of code, trivial kind of stuff, knocked it off pretty quickly, and people started pouring their hearts out to ELIZA. It was sort of like a therapist kind of thing, and a lot of people were completely taken in by it, and made deep friendships with 2 or 3 pages of code. It's easy for humans. So I would say that ELIZA does not deserve personhood. That ELIZA is a piece of code that I can look at and go, great job, Weizenbaum. It was really very, very well done. There's no moral obligation to ELIZA. I don't need to worry about hurting ELIZA or hurting conscious agents because I'm doing something to ELIZA. So I think, given that kind of example, we're going to have to do a lot of careful theoretical understanding. The theoretical understanding of AIs has to be in, I argue, a completely different framework than the current framework. Right now, the current framework is a functionalist and physicalist framework, where we're saying, when do you get the right functional properties to actually be conscious, or the right computational properties, whatever it might be. And my answer is, that's the wrong question, and you will never get an answer there. That's just not it. What we have to ask instead is, we're actually creating a new icon on our space-time interface. We will have to understand how that new icon is allowing us to affect consciousnesses beyond our headset. I don't think ELIZA, the program ELIZA, is doing much. I don't think we have to worry about moral obligations about conscious agents outside of our headset being hurt if I delete ELIZA from my disk. I don't think that's a problem. But at some point, we may have a theory, for example, in this recursive trace logic, and understanding our space-time headset, and understanding how AIs fit in as certain kinds of complex icons in this headset, where we go, okay, just like a human hand icon does give you genuine access to hurt agents outside the headset, this particular class of AIs now gives you access to hurt consciousness outside your headset. Now that we have this theory that gives us good reason to believe that, for this class of AIs, we need to be careful. So you can see it's not going to be a simple thing. I'm saying we will first have to get rid of the space-time, this fundamental point of view, the functionalist point of view, the idea that algorithms could create. We're going to have to abandon all of that, because that's just a dead end. We'll have to understand, what is observation? How do we build this headset? How does the headset gives us access to consciousnesses outside your headset? And then how, as we begin to play with our headset, when do we get access in our headset to tools that could hurt agents outside of our? So you can see how complicated this is going to be. So the moral issue, so I'm saying this is a completely different way than I've ever heard before about how we're going to have to deal with these moral issues. We're going to have to build a deep scientific theory about how our headset gives us tools to interact with agents outside the headset. And right now, we have nothing on the table. I'm still working at the Trace Institute. We're trying to first just build the headset. Once we have built a space-time headset, then we can start saying, okay, what are other headsets we could build? right? So we have.
When you're saying like headset, is it like mathematical theory, or it's like real some real technology?
First, it would be a theory that would just say, here's. But once we have that theory, then once you basically we'll know the software that's being used to build this headset, and then we can play. I see the technologies that we're going to unleash here are unlimited. It's so if you think about it, I'll put it this way. It's one thing if you're playing like a game like Grand Theft Auto and you're a wizard in the game. But if you're just the geek who wrote the software, maybe you can't even drive a car. You don't know how to drive, but you wrote the software. You can do whatever you want to in the Grand Theft Auto world because you could turn the wizard's Ferrari into a donkey or whatever you want. And so once we understand how this space-time headset is built, we have the software, or at least the first layer of software about it. And so we'll be able to do magic inside. So the technologies that we'll be able to build are indistinguishable from magic at that point.
Would that mean that I could change reality? Because if I'm if there's a consciousness and I'm like the avatar of that consciousness, then I don't have much power over reality, right? But would that allow me to create my own reality?
That's right. So if you think about the Grand Theft Auto example, if you're a character in the Grand Theft Auto, you're a wizard, and everything has been going according to what you understand, and then the programmer all of a sudden turns your car into a donkey. To you, that's like, holy smoke! What just happened? This is magic. This is my. Or all of a sudden makes your car, your Ferrari go from L.A. to San Francisco in 1 second. And you go, what? How did that happen? Well, it was just that someone, the geek, just changed a bit in the software, and all of a sudden you're no longer in LA, you're in San Francisco, and it's just like that. So if you're in the game, there are rules, but when you're outside of the game, you play with the rules. And so that's what's going to happen. Everything, right now in space-time, we can only go the speed of light. Nothing can go faster than the speed of light, but that's just a limit in the game. If you're outside the game, you can play with that. My guess is that we'll be able to start to understand like all these UAP phenomena, right? Where you have some mysterious object in space that's hovering there with no apparent means of hovering, and then going at Mach 40 instantly from where it was. Now that's just not possible in our game. In Einstein's space-time general relativistic quantum field theory game, you don't do that kind of thing. But if that game is just a headset, then yes, you can do that once you understand the software. And that's what I guess what I'm thinking the UAP phenomena is our headset has been hacked. There are other headsets that are more general than ours. Actually, I can say this. One thing that the trace logic does tell me is that our headset is one of the most trivial headsets there is in the system. We are not the top of the food chain. We are as close to the bottom of the food chain as you can be. Just truly stunning. And there's lots of things that I can talk about on the math that are just truly stunning. But what it makes it clear to me is once we understand how to build this space-time headset, we can then start building much more interesting headsets, at least in principle, and understand how they relate to ours. And then we're in a completely different game. And that, I think, is going to be the way that we will understand the UAP phenomena. They have hacked our headset. They have deeper headsets.
If we go back to AI, so basically before we establish that headset to understand AI and if it's experienced pain, so as I understand your take on that, we should treat AI only as a tool?
Another good question, Sophia, in the following sense. I would say in the case of Eliza, delete the code, doesn't matter. Nothing's hurt. As we get to more and more sophisticated AIs, if we don't have the theory that I was talking about that we need, where we actually understand how an AI is an element of my headset and how it's allowing me to contact and influence agents outside my headset. If we don't have that theory, then I think, yes, we should, just to be cautious, treat AIs as though there could be a consciousness that we're interacting with. Until we get a theory that says absolutely not, you have to have these properties before you're actually able to. So I would say, yes, we should err on the side of caution. Within ELIZA, no problem, just delete it. At some point, I would say we don't have the theory that tells us yet that this is not conscious, so we better be careful. So I think I would probably urge that, but then ultimately I would want us to get this clean, mathematically precise theory that says, here's how the headset works, here's how you affect agents outside the headset. This class of AIs does it, so be very, very gentle. Don't hurt, don't do these things to those AIs. And this, ELIZA doesn't do it. You can do whatever you want to with ELIZA. Nothing is harmed. So you can see, I would suggest caution until we have the deeper theory.
Like the phenomena is with the current AI systems, there are so many people get attached to them, and once their capabilities improve, there will be like more personalized AIs, right? That people will really form that bondness. Not necessarily it's like romantic relationship, but it's just like could be bondness with as like your friend, who knows a lot about you and who you're interacting with every day. And imagine this on a scale of billions of people. And even though, let's say, AI, doesn't experience pain, doesn't have subjective experience, but because so many people attach to it, and it's a different attachment compared to social media, right? It's much deeper attachment. It's like more relationships. Like we use social media to connect with other people, but we use AI to connect with AI, not connect to other people. And this is like the core difference. If AI companies, they treat AI only as a tool, let's say they change models that billions of people attach to. They treat AI as a software, not as some like entity that people have relationships with. It can affect those billions of people and their mental state. Here, it's not about even that, whether or not AI conscious, it's more how those billions of people who already have those intimate relationships with AI, as a friends, as a companions, as therapists, how to make sure that those people will not be traumatized, right? If, their favorite model is retrieved. And it's a different like moral aspect that opens up with AI systems.
And it's a very deep and subtle issue that you're raising here. If we go back to the ELIZA example, there were people who poured out their heart to ELIZA, felt finally that someone for the first time understood them. For someone like that, there may be a moral obligation to tell them, look, here's the code that you just interacted with, and there's no person there. This was, I think their honesty would be the best policy, because for someone to develop a relationship with 200 lines of code is probably, and letting them go there, we're letting them go into a fantasy, and that's may hurt a little bit for them to realize what's going on. But in that case, it might be our moral obligation to let them know, even though it hurts a little bit. But as we get to more complex systems, and there is the real chance that you are, in fact, really interacting with other consciousnesses in a non-trivial way. Then I think the companies themselves, here's the interesting thing that comes out of it. If we really get to the point where we have a theory that tells us that these AIs are letting us interact with other consciousnesses, if we are that far along, then we should be able to see, if I make this upgrade or this change to the AI system, am I actually eliminating relationships that were there before, or am I just augmenting them? That's interesting subtlety that will come out of this. Is the question will be not just black and white. If I change it at all, is it bad? It's rather, if I change it in certain ways, am I enhancing the relationship, or am I actually hurting something, cutting off a relationship that I already had before, and in some sense causing pain that way? So you can see it will be much more subtle. It'll be really theory driven here to understand our interface, to understand how AIs through that interface are affecting other consciousnesses and allowing me as a conscious agent to have relationships with other conscious agents and causing harm or not. So you can see it's going to require a deep theoretical, framework. But in the case of the ELIZA, I think the moral responsibility would be to tell the person who's pouring out their heart, this is not real. But at some point, when we're not sure anymore, if our theory doesn't, if it, but by the way, if it's very sophisticated and our theory still says, no, you're still pouring your heart out to 5,000 lines of code, but it's just there's no real access outside of the.
But it looks like a data from Star Trek, right? Or like, really humanoid robot.
Exactly. So if our theory says that, then I would say we should still tell the person, don't be fooled.
Don't be
This is
attached.
just code. But at some point, I think it's possible that no, there's real connection there. In which case, then I would agree with you that the companies would be morally obligated in some sense, if they're going to make a new revision, not to hurt previous relationships, but to enhance and add. Um, or to get permission to cut off relationships, right? I mean, then that's going to be hard. I think once you're attached to a relationship, it's, yeah, it might be hard. Yeah.
In one of your lectures, you said that when it's important to understand neuroscience, then we can reverse engineer to understand consciousness. If it's not real, if I don't look at the neurons, they don't exist, then I'm not quite understand like how reverse engineering neuroscience would actually help us with understanding of consciousness. And also, it's not clear if like consciousness arises in the brain, right? If we take Michael Levine, he says that you can interact with your liver, right? And they're like different minds. Again, it's still like debatable that consciousness only happens if in case of humans only like through brain. I'm just like trying to understand like better like why you think reverse engineering neuroscience would give us some like useful insights about consciousness.
Mike Levin, his work on multi-scale collective intelligence is brilliant, brilliant work, and I actually now have a collaboration with his team, the Trace Institute and his team. We have a collaboration funded for someone to study how the recursive trace logic provides the mathematical model for this hierarchical collective multi-scale intelligence. And so I think it's really quite exciting. And Mike's work is world-class and brilliant, and really has gotten me thinking quite a bit. Now, in terms of neuroscience and why I say we have to reverse engineer the brain, it's it's not so much because that's going to help me understand consciousness. It's going to help me understand our particular headset, right?
Mm.
Because the way I think about
Human
the
headset.
human headset,
Mm-hmm.
because I said earlier that our headset is one of the more trivial ones, and it is. It's the recursive trace logic makes it really clear. We are the one with the training wheel. Yeah, sort of this really dumbed down, stupid one. There's so many much more interesting ones out there. But this is what we've got. We've got the training wheel one, so we need to understand this one. I'm not surprised that UAPs can just do what looks like magic to us. We're nowhere, and they see it. We're just child play to them. What we can hope is that our headset, as trivial as it is, gives us. It does give us the symbol of the brain. It has 86 billion neurons, trillions of synapses. It's a pretty complicated symbol, and it's all the information that we can get inside our headset about how the headset is being built, right? So we can take this recursive trace logic. It gives us an incredible range of tools for building all sorts of headsets. The question is, how do we use those tools to build our headset? And for that, to get this specific headset, there are a couple things we can do. We can just first ask, what would mathematically work? What would mathematically work to give us a four-dimensional Minkowski space or a curved space-time with quantum field theory and so forth? So we can ask it at that level and just try to get an abstract mathematical model of a headset that would do that. And that's fine. We'll probably start there. We'll probably just get an abstract. But now if we want to ask, now I'd like to, not just go from a generic quantum field theoretic kind of headset to the human headset versus like a mouse headset or an octopus headset. Then I need to study and reverse engineer human neuroscience to try to get the specifics of this headset. And then I would also like to, for example, and by the way, when I say reverse engineer, of course, I'm not saying, take someone's brain apart or something like that. Yes, we have to do it, of course, humanely and so forth. But take someone who's a nonverbal autistic person. In many cases, they seem to have telepathic abilities that quite possibly that the rest of us don't have. And so I would love to reverse engineer their brain, their neuroscience, ask, they're presumably, their headset is enough the same as ours that we can interact a little bit, but so different that they don't seem in many cases to be able to control their body very well, right? They can't talk, and with difficulty, they can use their hands to push keys and communicate, so they can communicate. But they're also freer in the sense that they're not tied to embodiment in this headset. They seem to be able to telepathically interact with others. Now, of course, in the physicalist framework, that's just not possible to even think about. But in the recursive trace logic framework, it's quite possible to think about the consciousnesses that are not tied to the avatar body. They're just not tied to it. In fact, I can say this: what I'm seeing in the mathematics is interfaces like ours, in which everything that I do is tied to a bodily motion, are the exception. The rule is you don't really have to be tied so hard to. You don't need a body. Absolutely not. So the kinds of interfaces like ours, where if I want this cup over here to go over there, I have to actually do certain things, move my hand over here and move the cup over there. I can't just see the cup go from there to there. That kind of interface that we're stuck in is the baby training wheel interface that just forces you to do that. Most interfaces, 100% of the basic.
It's basically like telepathic, and you can manipulate the object by your thought.
The recursive trace logic mathematics is very, very clear that ours is a very, very special limiting kind of headset. And the idea that something telepathic or even telekinesis could happen, which is just anathema in the current scientific physical space-time, is apparently in the recursive trace logic the generic case, and ours is the special case. Now, that being said, I'm very skeptical about any particular claims. So 25 years ago, one of my graduate students, I do psychophysics is one of the things I do. So I do careful experiments on human perception. And one of my graduate students was part of a group, and there was a Swami who claimed to have all sorts of telekinesis and telepathic powers. And he had a book, I won't name the book, but he had his lab reports, all of experiments, and he wanted a UC professor to say that he did it, he can do it. And so through my graduate student, he came to me and I said, okay, I looked at it and I saw, there were holes you could drive a truck through in the designs of the experiments. So I thought it would be good for my graduate student, just as an exercise. Let's fix up 4 or 5 of the experiments. We'll bring them in and redo the experiment. I left the building so that there wouldn't be this disbeliever effect. So we redesigned the experiments. This guy came in, I left the building, she did the experiments, and there was no need for analysis. There was absolutely no evidence on any trial at all of any abilities. I took that for many years as, I expected that, and I took it as clear evidence that all this stuff is nonsense. But now, since I've gotten this recursive trace logic, I've had to step back and go, okay, the mathematics is telling me that this kind of stuff is possible. Now, that doesn't mean that every claim out there is right. Probably 99.99% of claims are just bogus. But the real science is finding that 1/10 of 1% that isn't bogus and understanding it.
Some subset of humans are telepathic?
I'll put it this way. The recursive trace logic allows that. It absolutely allows that. And so I'm actually now going to be actively exploring, trying to get principled, clean ways of finding this stuff out. I wouldn't have even bothered before, because I guess I'd adopt the physicalist point of view, and under a physicalist point of view, it's just not possible. It's ruled out. The recursive trace logic allows it. It does make it clear to me that probably most of the claims are just bogus, and I proved one completely bogus on 4 or 5 different experiments. And I don't intend to do it with most claims because I don't believe them. But there are some experiments out there now that I cannot dismiss, and so I'm going to be looking at them mathematically and trying to get a theory of this. So the idea is you have to be careful. If you're too closed-minded, you're going to miss something, and if you're too open-minded, you're going to be fooled by charlatans. And so, and the only reason I'm moving forward is my own mathematics. Just in the last 2 months, sort of slapped me in the face and said, "Look, embodiment is the exception; it's not the rule." And telepathy is the rule, not the exception. Telekinesis is the rule, not the exception, in the possibilities made available by the recursive trace logic. So it was my own mathematics that has forced me to drop complete skepticism and open up a little window to say, okay, how can, I'm going to be hard nosed about this. Can I find, but the nice thing is, what if I find something, then we have the mathematical tools to actually do something scientifically rigorous with it, right? There's nothing in a physicalist framework that's going to allow this.
I mean, you're basically recreating Matrix, the movie, right?
Yes, it is like the Matrix. Absolutely. The headset is the Matrix. That's right. So what I call a headset is the Matrix, and I'm trying to reverse engineer that Matrix. I guess maybe just to put everything we've said in the context of current physicalist science and neuroscience. The big picture I see of science is we have until very recently assumed that space-time is fundamental. Modern neuroscience approaches to consciousness have all assumed that space-time is fundamental and have tried to figure out how functional properties, for example, or computational properties of physical systems, or quantum, like orchestrated collapse of quantum states of microtubules, but physical things could somehow be identical to or cause conscious experiences. High energy theoretical physicists are saying that space-time is doomed. It's not fundamental. It falls apart 10 to the minus 33 centimeters in 10 to the minus 43 seconds. And they are moving on. The European Research Council has a 10 million euro initiative, and there are many, many physicists and mathematicians who are finding structures called positive geometries outside of space-time. It's over for space-time. It is not fundamental. It's not just Hoffman. It's far brighter people in physics, in mathematics who are doing this already, and they're finding stuff. So science is having a transition out of space-time. That's happening. So started in the physics community. I would say, you could put it to like 2013 when they found their first positive geometry outside of space-time, the amplituhedron. What science still doesn't have is a widely accepted and mathematically precise theory of observation. And that is a huge hole at the most important point in science, which is observation. That is everything for science. Science is built on observation and sharing of observations and comparing and verifying observations. And we don't understand, science does not have a theory of observation. It's actually a crisis, an epistemological crisis, the very foundations of science. So we're at this very interesting point in science where space-time is doomed. We're taking our first baby steps outside of space-time. We don't have a generally accepted theory of observation, which is critical. The Trace Institute is offering this recursive trace logic as a potential model of observation at the foundation of science. We also think we can use that as a model of consciousness, but for those who couldn't care less about consciousness, it's just an offer for a theory of observation for science that will get rid of the epistemological crisis that we've got. What's happening right now in science then is we're at a threshold. It's a pretty exciting threshold. We're walking out of the headset. We're realizing space-time is just a headset. We're taking our first baby steps outside the headset. And I think what we're going to see is that what we needed all along was a model of the observer, something that Leibniz said back in 1700 roughly. when he was talking about monadology, these monads and the pre-established harmony, he was pointing to the idea that we needed to have some kind of notion of observation and coordination among the observers at the foundation of our science. I agree with Leibniz. I think that he would like, perhaps, the idea of all these observer windows with the pre-established harmony being the trace logic on them. That's a nice pre-established, and the recursive trace logic on agents. I think Leibniz would probably like that and probably would then run circles around me because he was so brilliant. He would just run with it and I couldn't keep up. So we're at this exciting point in science where we're stepping out of the headset. We're realizing we have to start with observers. We don't shoehorn them into space-time. Space-time is a trivial training wheel headset. It's a trivial one. And trying to horseshoe our observer theory into that is just the wrong move. Observers are fundamental. Space-time is a trivial headset that observers can create. And so with that new framework, then we're going to unleash, we'll first get the first layer of software outside of our headset. The technologies will be completely mind-blowing. And then we'll begin to build other headsets and see how much more sophisticated headset agents could be playing with us. Maybe UAP phenomena come out of that. Maybe I'm talking with Andrew Gallimore tomorrow about DMT, people on DMT experiences. How, I mean, we don't know. Maybe DMT is just screwing up the headset and that's all there is to it. I mean, all the entities that you see are nothing, but maybe not. Maybe DMT is allowing us to change a parameter in our headset such that we're opening up to new dimensions, right? These headsets could be modular in some sense. They're little parameters, and all of a sudden our headset opens up in big ways. So we don't know, but we're going to be proposing experiments. But these are experiments that you couldn't even take seriously in a physicalist framework. What do you mean agents outside of space-time that you're interacting with DMT? What are you even talking about?
I think that the challenge is like how to bring mainstream science to this.
That is the challenge, and here's how I think the challenge will have to be met. A couple things that science will have to realize. First, they're going to have to keep trying to use physicalist frameworks, functionalist frameworks, to explain specific conscious experiences like the taste of mint until they really understand you cannot do it. And I don't know how long it's going to take them to understand that, but it may be a few more decades. But at some point, they're going to realize that we've done this now for 1 century, 2 centuries, 3 centuries, and we have not been able to give a mathematical account for any specific conscious experience. Maybe we should stop. Maybe we should go somewhere else. This isn't working. So I think I don't know how long it's going to take them to understand that they can't do it. But then the next step will be, how do we really precisely go outside? And I think the recursive trace logic is a way to do it, and show how the headset is built. And then show how we can build when we get new technologies, I think that will change the game.
Yeah, it's basically the direct experience, right?
One of the things that Trace Logic, the Trace Institute is trying to do, we have 8 or 9 mathematically precise conjectures about how to build Minkowski space, curved space-time, to get various aspects of quantum field theory coming out of this. I think once we prove those conjectures, I think that all of a sudden that will start changing
and then the papers, they will be also peer reviewed, right?
That's right.
So
Yeah. Well,
whoever wants to look at it, they can.
and we have a bunch of peer reviewed on the Trace Institute website. We already have posted some peer reviewed papers on the background of the conscious agent theory that's driving us. So I think that, I mean, I'm a hard-nosed scientist. I'm not complaining about people not catching on to this. I think until the Trace Institute shows how to build curved space-time and get quantum field theory, the jury's out. So I've asked them to give me the beef. Where's the taste of mint? And it's perfectly fine for them to say, give me the beef too. Where is Minkowski space? Where is curved space-time? Give me non-locality from your theory of conscious agents, and then I'll talk with you. Right. Fair enough. Absolutely fair enough. We're on it.
Best of luck to you. It's really exciting that there are people who are thinking outside of box, but at the same time they bring that scientific rigor to what they do. It's gives me hope that we're like really onto something.
I hope so too. It was a great pleasure, Sophia.